This is the first of two short videos recapping linear equations. We'll begin with the four building blocks. Here we have four simple linear equations and we're trying to find the values of x that make them true statements. Example 1. X plus 2 equals 6. Well, if x has had 2 added to it, to get x on its own we'd have to do the opposite and take 2 back off. But to keep the equation balanced, if we did it to the left hand side, we'd also have to do it to the right hand side. So on the left we've now got x, and on the right we've got 6 minus 2. So x is 6 minus 2, which is 4. Example 2. This time x has had 3 subtracted from it. So to get x on its own we'd have to add that 3 back. But if we did it on the left hand side, we'd also need to do it on the right hand side. So we've now got x on the left and 5 plus 3 on the right. So x is equal to 5 plus 3, which is 8. Now, to be efficient in solving equations, we need a shortcut. So I'm going to rub out the second line. And let's have a look at what has happened. The first line says x plus 2 equals 6, and the next now says x equals 6 minus 2. So it just looks as if I've moved the plus 2 to the other side of the equation, passed it across, but changed its sign. Same for example 2. X minus 3 equals 5 becomes x equals 5 plus 3. So it looks as if I've just passed the minus 3 across the equal sign, but changed its sign. And that's what we do when we solve equations. We pass terms backwards and forwards across the equal sign, but you have to change their sign if you do so. Example 3. 2x is equal to 10. So x is equal to 10 divided by the number of x's I have, 2. So x equals 10 divided by 2, which is 5. Example 4. X divided by 3 equals 5. Well, if x has been divided by 3, I'll need to multiply 3 to get the full x. So x is 5 times 3, which is 15. So if we've got x over a number, to get x on its own, we multiply through by that number. Now let's put these ideas to use solving slightly more complicated equations. Example 5. 2x plus 3 equals 11. So the first thing I'm going to do is get the x's on their own. And I'll do that by passing the plus 3 to the other side of the equation. But when plus 3 moves across, it becomes minus 3. So 2x is equal to 11 minus 3, which is 8. And now we're going to say x is equal to 8 divided by how many x's I have. So 8 divided by 2. So x is 4. Now let's check that answer in the blue equation at the top. 2 lots of 4 is 8, plus 3 is 11, and so it's a true statement. Final example, example 6. I want to get the 3x term on its own, so I move the minus 5 to the other side, but when I pass it across, it becomes plus 5. So 3x is 10 plus 5, which is 15. So x is 15 divided by how many x's I have, and 15 divided by 3 is 5. Let's check that answer in the blue equation at the top. 3 lots of 5 is 15. 15 minus 5 does indeed give 10. So it's a true statement. And that's the end of the recap.